of linear functions. And I think this first question is probably super easy, but just to go over it with everybody, making sure you know how to do it. This question says a rectangle has a width of 45 centimeters and a perimeter of 210 centimeters. What is the rectangle's length? Fairly simple. I would always, when I work with like geometry shapes, I draw it and then I label. So my width is 45 centimeters. So I put 45 here and 45 also over here because it's a rectangle. And then I know that the perimeter is 210. And I need to know what the length is. So I'm going to call this L and this side L. And if you remember perimeter, you might even remember the formula for perimeter of a rectangle. It's 2L plus 2W, or you could just add up around the rectangle. That's what a perimeter is. So L plus L is 2L. 45 plus 45 is 90. And you're going to set that equal to the perimeter, 210. And then you just solve. So 2L equals 210 minus 90 is 120. And then divide by 2, so the length is 60. So you have a question that simple for the end of the homework, which will be good. And then it goes straight into mixture problems, which mixture problems can get confusing. You may have done them in chemistry, but I'm going to show you how I teach them and how I do them. Hopefully it'll make sense. I make these charts with them. So we will do this first mixture problem. It says how much of a 70% orange juice drink must be mixed with 4 gallons of a 30% orange juice drink to obtain a mixture of 50% orange juice. So the way I always do this, and I always set it up, is I make 3 columns. And in those 3 columns, you have what you're starting with, what you're going to add, and then your new mixture would be the bottom. So not only do you have these 3, I should actually say rows, but you do have 3 columns. In this first column, it's the percentage of whatever. In this case, it's percentage of orange juice. Maybe it's percentage of alcohol. Maybe it's the percentage of a solution, an acid solution. So you put in this case, we want percentage of orange juice. Then you're going to multiply that by an amount. How much of that do you have? And then in this column is going to be your total. And from that last column, we're going to write an equation. So let's read this again. How much of a 70% orange juice drink must be mixed? So that right there, how much of 70%, that right there is what we're adding. How much of this 70%? So we're going to add 70%, and I'm going to write it as 0.7. 70% is 0.7. How much of it do I add? I don't know. That's my unknown, so I'm going to call it X. That's the amount of X. And what am I adding it to? Well, I'm adding it to my start. I'm adding it to something that I started with. I started with 4 gallons of a 30% mixture. So I have a 30% mixture that I started with, and I had 4 gallons to start. So how much should I add? Should I add 5 of this 70% orange juice? Should I add 12? What should I add? And I want it to now be to obtain a mixture of 50%. I want it to now go to 50% orange juice. What would be the amount of my new mixture? Well, I had 4 to begin with. I added X amount, so X plus 4. Now in this column right here, so this is the main part right here. This is where you use your information from the story and put it in your category. In this last column here, you do a total. You do this times this, this times this, this times this. So 0.3 times 4 is 1.2. It's 1.20, but I'm just going to write 1.2. 0.70 times x, I'm just going to write 0.7x. And then this one would be 0.5 times x plus 4. Okay? This right here, this total is where you're going to write your equation. And your equation is what you start and what you added equals that guy, equals the new mix. So I had 1.2 plus 0.7x equals 0.5 times x plus 4. And this goes back to what we just talked about really in the last section about these decimals. If you notice, everything is in tenths. Had you left it with hundredths, you would have multiplied by 100. But I left it as tenths, so I'm going to multiply this by 10, this by 10, and then this guy by 10. And so now I'll have a 12. Here I'll have, move it over 1, I'd have a 7x. And then 10 times 0.5 is 5 times x plus 4. And now I can just solve it. Oh, and let's see. 2x equals 8x is 4. So I would have to add 4 more gallons of this 70% orange juice mix to get a new concentration of 50%. Okay. I know that you haven't done this in a while and it's a long time, but I promise you, if you could understand this and label it like this, you'll have one just like it. I think they changed the 70% and obviously they changed the 4, but you just label yours like this, it'll come out quite easily. I'm going to do another one about adding pure alcohol to a solution. So I want to do that, the same setup. Okay, what you start with, what you're adding. In this case, we're adding pure alcohol. That's important. And we're going to get this new mix. And then you have 3 columns this way. You have the percentage of, what are we talking about? Of orange juice? No, the percentage of alcohol. You're going to multiply that by an amount. And you're going to equal a total. And so you always start your these mixture problems like this. Okay, so let's read it. How much pure alcohol should be added to 20 liters of a 40% alcohol to increase the concentration to 50% alcohol? Okay, so how much pure alcohol? That's an amount. How much alcohol are you adding? I don't know. We'll call it X. What is the percentage of alcohol in alcohol? This could be tricky to some people. What is the percentage of alcohol in alcohol? Well, it's 100%. There's 100% alcohol in alcohol. I'm not talking about, you know, beer or something cheap like that. I'm just talking about pure alcohol. 100%. So the way we write that as a decimal will be 1. So how much pure alcohol should be added to, this is what we're adding it to. So this is what we started with, 20 liters. We started with 20 liters of a 40% alcohol, so 0.4. To increase the concentration to 50. So now we want this new mixture to be increased, because when you add 100% of something, you're making it more alcoholic, sorry. So 0.50, and your amount, well, if you had 20 and you added X, you would have 20 plus X. We don't know how much we're adding, so we'll just call it 20 plus X. So now multiply these together, multiply these together, multiply these together. So this would be 8. This would be x, or 1x. And this would be 0.5 times 20 plus x. And then again, your equation is these two together, 8 plus x equals that one, 0.5 times 20 plus x. So 8 plus x equals, 10 plus 0.5x. And again, you can get rid of the decimal. You can just, we're working with 0.5, so that's actually not terrible. 0.5x equals 2. X is 4 again. 4 liters. Okay. All right. Now, they also asked this question I saw on my math lab. It says, suppose a chemist mixes 2 acids, a 25% acid and a 35% acid. Which of the following cannot be obtained? 27%, 30%, sorry, mine got cut off, 33%, or 39%? Which cannot? Well, when you're mixing a 25% and a 35%, you're never, ever, ever going to get greater than what you have here. So right away, you could have a 27, you could have a 30, you could have a 33, but you cannot have the 39. That one is the one that cannot be obtained. So I thought that was an interesting question they asked, and I wanted to make sure I did one like it. All right, last 2 questions. They look wordy, but they're not too bad. Last 2, and we'll be done. Okay, and these are cost revenue questions. So if you're like going into business, you would see a lot of this, but students stuff envelopes for extra money. Their initial cost to obtain the information for the job was $520. Each envelope costs 5 cents and they get paid 9 cents per envelope stuffed. Let X equal the number of envelopes. So you are to express the cost C as a function of X. Okay, so the way we write that is C of X. Now remember, we always have a rate at which we're getting paid to stuff these envelopes. So let's see, each envelope costs 5 cents and their initial cost was 520. So every time they stuff an envelope, it costs 5 cents per envelope, which X is your envelope. And then their initial cost was 520. That's your initial cost. That is the cost per envelope. And then obviously X is your number of envelopes. So we just expressed your cost function. Very easy. 0.05x plus 520. Express the revenue as a function of X. So revenue is capital R of X. Your revenue, they said, they get paid. What do they get paid? They get paid 9 cents per envelope stuffed. So 0.09x. That's their revenue. Part C says, okay, determine analytically the value of X, which the revenue equals the cost. So you're going to set this equation equal to that one. Or vice versa. I'm going to do it a flip way. 0.05x plus 520 equals 0.09x. And again, you can multiply everything by 100. I mean, these are actually pretty easy to do and use your calculator. 0.04. And then let's see, what is 520 divided by 0.04? 13,000. So at the 13,000 envelope, your cost would finally equal, your revenue would equal your cost. And that's what the question would ask. So you have a question just like that. And then I wanted to do one more similar because they think there's two of them just like that. And this one is a cost, let's see, a truck driver operates a delivery service in a southern city, and his startup costs amount to $2,400. He estimates that it costs him, in terms of gasoline and wear and tear on his truck, $4 a delivery. He charges $6.50 per delivery. Let X represent the number of deliveries. So again, we're doing the same thing. Express C as a cost function. So my cost function would be C of X equals, what are we getting? Let's see, what is it costing him per delivery? It's costing him $4 per delivery. And then his startup cost, his initial amount was $2,400. Then part B, express revenue. What's he getting paid? What's he making? He's charging $6.50 per delivery. So 6.5x. Part C, determine analytically the value of x. So exactly what we just did before, set these two equal to each other. And you get 2,400 equals 2.5x. So 9, at the 960th delivery, he should start making, I hope, a profit. And then part D, this question they ask you, they say graph on y1 your C of x function, and graph on y2 your revenue function. So 4x plus 2,400. Ooh, there we go. And y2 is 6.5x. I'm going to tell you right now, you don't want to hit zoom 6 because you're only going up, down 10. And I can already tell here I have 2,400. So you could do the whole, you know, actually, I want to try zoom fit if I remember correctly. Let's see if it'll actually zoom fit it. It's not in my viewer window. Oh, that's terrible. My zoom fit did not work what I wanted it to work. I'm going to change my window. So I'm going to say, let's see. Come on. Oh, thanks for graphing the one line. Second, no, window. Here we go. Okay, so it looks like I have x values of 960. So I don't think I'm going to have negatives. Obviously, we're trying to have some x and y values. So my max x value, 960, I actually would probably go higher than that. I'd probably go to like 1,000. The scale at which I would do it would probably be like, I don't know, 100. My y-min, again, I'm staying in that first quadrant because we're actually talking about, we don't have negative deliveries. So we'll do 0. Or y, the cost, or negative amount of money. Y cost would be, it's 2,400 here, but you always want to go higher than that. I think I tried 2,400. I think I'm going to go up to like 7,000. Woo. And a scale of 500. And we'll see if we can see the graphs intersect there. So you kind of have to play with it. You kind of have to give a guess. Is it intersecting? Yes. Okay. So it intersects right there. I think they'll give you scales. You can always look at the MyMathLab. They always give you those scales. Remember, they write it like interval notation. So my X scale was like 0 to 1,000. And my Y, I think, was 0 to, what did I do, 7,000? That was my range. So you just want to look at it and then interpret the graphs. I mean, obviously, they'll have questions like that for you on MyMathLab to look at. But that is it, everybody. That is